In this problem, we're asked to approximate a binomial probability using the normal distribution. So we're told that a certain flight arrives on time 86% of the time, and suppose 198 flights are randomly selected. We will use the normal approximation to the binomial to approximate these probabilities. Now, before we get into that, I took a screenshot here from our e-text about the normal approximation to the binomial probability distribution. The first thing we need to do is check this condition that it's met. And then after that, we need to calculate the mean and standard deviation. So in order to do so, we need to identify n. N is the number of trials, and that is 198. And we also need to identify p. P is the probability of success, and that's this 86% written as a decimal. So I've already put that stuff in my calculator. The first line here is the condition, n times p times 1 minus p, and I can confirm that that is greater than or equal to 10. N times p is the mean. So this 170.28, I need to hold on to that value. And standard deviation is the square root of the condition, actually, if you look at it like that. And we have 4.8825. That's the value we'll use for our standard deviation. I would try to be as precise as we can be here with the standard deviation. That could make a big difference in our next steps. So that's why I'm choosing to go 4 decimal places with that. So again, we'll just keep track of these two numbers as we proceed. So now let's get into these probabilities we're asked to find. Like for instance, in this first one, we're asked to find the probability that exactly 160 flights are on time. Now, remember, we're not using the binomial distribution. We're using the normal distribution to approximate it. And part of the issue with doing so is the normal distribution is continuous. So, and we're using this continuous curved, remember if you recall like this, these curves, I'll go ahead and show you here, in order to approximate a discrete distribution. Think something that looks a lot like a bunch of little histogram bins, right? So for part A, where we're asked to find the probability that x equals 160, we will need to add and subtract 0.5 from 160 as a correction for continuity. Again, because we're using this continuous function in place of or to approximate rather, the discrete probability. So I've referenced here table 5 in section 7.4, and I could not capture the entire screenshot, but I've got some of it here and enough for us to at least do parts A and B. So in this table, we have the probability we're finding exactly with the binomial, how we can account for the continuity that's in the normal distribution. Okay, so remember back up here, we have to correct for that continuity, and then that graphical depiction. So I'm going to fill this table in with what we're being asked to do here in part A. So in order to find the exact probability using the binomial, that's what we were presented with, find the probability that x equals 160. What we are doing is we are going to approximate that probability with the normal model. We have to correct for continuity, so we add and subtract 0.5 from that special value that we're looking for. So in other words, I now have this small area that I'm going to look for between 159.5 and 160.5. Graphically, that shows up over here as this is exactly, let's say 160, and what we're going from and to is the 159.5 to 160.5. In other words, it gives me this really small bin that is fairly close to what's under the curve, the normal distribution, within 159.5 and 160.5. Keep this table handy as you are doing these types of problems, using the normal distribution to approximate a binomial probability. Next, we're going to now turn to StatCrunch. We'll use stat, calculators, and normal to help us find these values. So stat, calculators, normal. In this space, this is where we will give StatCrunch what we calculated as our mean and standard deviation. So I went ahead here and typed in those values. Next, I'm really doing a between type of probability. StatCrunch first assumes you might want a standard one. That's just x is less than or greater than or equal to a particular value. But we want to do the between type. And here's where we will give StatCrunch 0.5 below our desired value, which was 159.5, and 0.5 above our desired value, which was 160.5. And then when we select compute, we see what looks like approximately a small little bin from a histogram. That's exactly what we wanted to see. This is approximately what that full bin would have looked like. So we'll grab this value here and round to type back into my math lab. I think when we round there, that would be 0.009. So come back up, let's see, and I did have that earlier, 0.009. I'm going to do at least one more of these that show you how to work with the normal distribution as an approximation to the binomial distribution, but continue to rely on this table that's in section 7.4 for the rest of these problems. So this next one is probability that x is greater than or equal to 160. So when I come back down to my table, I had to grab more of a screenshot here from the text. That would most closely match this particular row. So I'm looking at the probability that x is greater than or equal to a. In this case, I would have to replace that with 160. Here is kind of the formula. You might want to think of it as how I can use the normal approximation to, or normal distribution rather, to approximate the binomial. I would need to then subtract by 0.5. But honestly, I rely more on the visual. So let me show you here what I'm thinking. So if I want this to be 160 and I want to capture this probability, also known as this area under the curve for this particular distribution, and let's say I go right at 160, 160 and above. The problem is I'm not capturing enough below to approximate that what would have been that first bin here. So I need to back up 0.5, and so really I'm going to use 159.5 in here. So that would be 160 minus 0.5, or in other words, the probability that x is greater than or equal to 159.5. That's what I'm going to do inside of StatCrunch. So let me come back to StatCrunch. Mean and standard deviation are the same. I do need to switch back to standard in this case, and I'll select greater than or equal 159.5 and compute. And so now I see that 160 is included. Imagine again that little bin that would be right here, and then all these other bins that would make up this area. And so I get this value. I would need to round that 3 to a 4, right? So 0.9864. If we come back to what we had answered earlier, that's that 0.9864.